Hi class, this is Jane Magana and I'm doing questions 7 through 11. So here's question 7. Use the whisker plot and estimate the shape of the distribution. Insert the picture of the graph and provide a sentence explaining your conclusion. The values that our group found were Q1 equals 62, the minimum value is equal to 45. The distance from Q1 to the minimum value is Q1 minus minimum value equals 62 minus 45 equals 17. So we have Q3 is equal to 76 and the max value is equal to 89. The distance from max to IQR is max minus Q3 is equal to 89 minus 76 equals 13. Since the IQR is closer to the maximum values, the distribution is likely skewed to the left. The possible outliers are 45 years of ages. The maximum value is 89 years ages again. And so here you can see in the graph that we are closer to the maximum value than the minimum value. Question number 8. Use the empirical rule or Chebyshev's theorem to provide a prediction of the spread of the data set that is within 3 standard deviations from the mean. Only one theorem applies based on the answer for question number 7. Provide the interval, percentage, and proper sentence in your calculations. We estimated that the data is not bell-shaped, hence Chebyshev's theorem applies. Using Chebyshev's theorem, the percentage of senators whose age falls within 3 standard deviations of the mean is the interval of dispersion is x bar is equal to 68.76, standard deviation equals 10.6050, k equals 3. Chebyshev's rule equals 1 minus the fraction 1 over k squared times 100%, giving us 1 minus 1 over 3 squared times 100%. 88.89% lie within the interval, which is x bar minus ks to x bar plus ks, which equals 68.76 minus 3 times 10.6050 to the higher end, 68.76 plus 3 times 10.6050, giving us the interval of 36.945 to 100.575 ages. And as we round to the nearest values, we find, according to Chebyshev's rule, at least 88.89% of senators' age lie within the interval 37 to 101 ages. Question number 9. Create a confidence interval for the population mean. Use 90, 95, or 99 levels of confidence. Provide the critical value, a sketch of the critical value, the standard error, and all formulas and calculations. Clearly state the parameter you are estimating. Use technology for the sketch and to confirm the final answer. Insert a picture that confirms your final answer, TI or StatCrunch output. Our group is using a 95 confidence interval. N equals 100, degrees of freedom equals 99, S equals 10.6050, X bar equals 68.76, C equals 0.95, and alpha equals 0.05, with alpha over 2 equaling 0.025. The critical value here is a t-score. It is 1.9842, again with a confidence interval 95. And it is a positive value with 99 degrees of freedom. Here it is, 1.9842. The standard error is E equals the value of the t-value of alpha over 2 times S over the square root of n is equal to 1.9842 times 10.6050 divided by the square root of 100, which is approximately 2.10424. The standard error is 2.10424. The 95 confidence interval for mu, where x bar minus e is the lower end, or less than mu, which is less than the higher end, x bar minus e. So we have 68.76 minus 2.10424 is less than mu, and mu is less than 68.76 plus 2.10424. giving us an interval here, 66.65576 on the low end. Mu is higher than that. It is lower than 70.86424. The confidence interval for mu is approximately between the ages of 66.6557 and 70.8642. Here we have StatCrunch confirming our lower and upper limits. So 66.6557 and then 70.8642. Question 10. Okay, question 10. Create a confidence interval for the population standard deviation. Use 90, 95, or 99 levels of confidence. Provide the critical value, a sketch of the critical value, the standard error, and all formulas and calculations. Clearly state the parameter you are estimating. Use technology for the sketch and to confirm the final answer. Insert a picture that confirms your final answer. Our group is using a 95 confidence interval for the standard deviation. The standard error does not apply to the population standard deviation. N equals 100, DF equals 99, S equals 10.6050, X bar equals 68.76, C equals 0.95, alpha equals 0.05, alpha over 2 equals 0.025. So we have a chi-square distribution with 99 degrees of freedom. The critical values are chi-squared left being 73.3611 and chi-squared right being 128.422. So the 95 confidence interval for sigma is where we approximate sigma between these two values of the square root of n minus 1 standard deviation squared over chi-squared r. And like I said, we take the square root of that collectively. And then we have on the high end the same equation almost. It's the square root of n minus 1 times s squared over chi squared left. And so we have 100 minus 1 times 10.6050 squared over 128.422, and we take the square root of that, is less than sigma, which is less than the square root of 100 minus 1 times 10.6050 squared over 73.3611. So that gives us this 9.31126 is less than sigma, and sigma is less than 12.31956, which means the confidence interval is on the low end 9.3113 and on the high end 12.3196 ages. The StatCrunch output for the variance of age members shows us a lower limit and an upper limit that are these numbers squared. A note, the standard deviation is S equals the square root of the sum of x minus x bar squared over n minus 1, taking the square root of that, is approximately 112.4671 square, or the square root of, is equal to 10.605. And the lower and upper limits are the square roots here, as we can see from the output of the variance. 86.69961 square root to 151.77.171 square root of that, which is approximately 9.3113 to 12.3196. And question 11. Design a hypothesis test for the mean, proportion, variance, or standard deviation. I strongly recommend that you pick the same c-value and parameters selected in questions 9 or 10. Provide a sketch of your solution. Your sketch should include critical values, test statistic, and p-value. Use technology for the sketch. Provide all formulas and any calculations. Use technology to justify the p-value found. Insert a picture that confirms your final answer. And include the proper wording in the conclusion. So our claim is that we claim that the population is from a population mean of 65. Here we state our hypothesis. Our null hypothesis is mu is equal to the age of 65, and our alternative hypothesis is mu is not equal to 65. The critical values are alpha is 0.05, C is 0.95, and alpha over 2 is 0.025. The critical value here is a t-score, which is 1.9842 with 99 degrees of freedom and c equaling 0.95. So we have a critical value that, again, is right here, plus or minus 1.9842. The test statistic is t equals x bar minus mu over s over the square root of 9. The square root of n, rather. X equals 68.76, mu equals 65, the standard deviation equals 10.6050, n equals 100. So we have t equals 68.76 minus 65 over 10.6050 over the square root of 100, which is approximately 3.5455. So this is a larger number than our critical values. The test statistic is t is approximately 3.5455. So let's confirm with our p-value, which is 6 times 10 to the negative fourth, which is approximately 0. We did a t-test with our calculator, and then we have StatCrunch output hypothesis, which is going to confirm that our p-value is around 0. And so our conclusion is to reject HO, since the test statistic of t approximately 3.5455 is greater than the critical value of t approximately 1.9842, and our p-value is approximately 6 times 10 to the negative 4, which is about 0, and is less than alpha equals 0.05. When using a c equals 0.95, there is sufficient evidence to warrant rejection of the claim that mu equals 65. Thank you. Have a nice day.